Okay, so before we turn on, the first thing we're going to need is water and power. I firstly want to demonstrate when there's no water on, so you understand how the flow sensor won't allow the machine to start. So water's off, power's on, 20 amp supply. So we press start. First thing that comes up is no flow. Without water, the machine won't start. So while we're on this screen, I just want to touch on all the parameters that are set here. So we've got firstly pump pressure, secondly we have oil pressure, thirdly we have our water temperature. Obviously there's no flow, stop. I'll go back to the main screen in a moment. The other thing then, really important for your checks and observation, is your pump hours. It's like a car, everything runs on kilometres, and that's when we know what the machine needs and when. So this machine here has done 8 hours and 47 minutes. The ACW actually stands for anti-clockwise. This machine will automatically run the right way in sync with your power. So this one says ACW anti-clockwise. Okay, so the valve here is open. Just for your information, I explained to cleaners, because sometimes they're not aware or understand, that when the valve handle is vertical with the pipe, means it's open. That's if the handle is on the right way. Occasionally I see them on back to front, so we know now the water is open. Okay, so now the water is on, the power's on, I'm going to press start. Obviously there's no flow because the gun on the end of the hose is in the closed position and not open. So I just want to briefly touch on the run sequence. So we press the start button. That sends the signal to the flow sensor. It will run for 3 seconds. The PLC will check the parameters. If the parameters are correct, the machine will continue running. If the parameters are not correct, the machine will stop. So 3 seconds is our time delay. Okay, so here we're looking at pump pressure, fluctuating between 35, 37 bar. Oil pressure, 270, 280 kPa. Water temp, 30 and climbing. It'll take time obviously just to sense what water pressure. That's with one rinse jet. Okay, now I'm going to put another nozzle on. Okay, we can see now we've gone up to 75 bar and fluctuating slightly. The rest will be the same. Water pressure is still climbing. It just takes time to read what its top temperature is. And I didn't note before, we've got flowing. So we're flowing, the water's flowing. Okay, so next thing I want to talk about is the chemical block or mixing valve. So we change directions with this handle. So currently here we're in wash mode. We move to foam is the blue side, and then to sanitize is the yellow side. We're actually going to foam up shortly, but I just want to give a little tutorial on this one. So we'll see here we've got our pickup lines. So there's a check valve, a one-way check valve underneath. So we've got our blue side, our yellow side. There are tips within there which limit how much chemical that you're using. And this is the actual body, the stainless steel block. There's a module here for air, so if you're not running at higher pressure, you're running at low pressure of 2 or 3 or 4 bar, we can inject air and get a good quality foam. Okay, so the O-ring has come out, so we're going to film putting it back in. There's a bit of a trick to it, so I usually curl it like that. Put it in and then just put it in. And I've been doing that for 25 years, it's not that easy, so you master it after that long. Okay, so with the machine we use here, the SRT, this is a foam blasting nozzle here, so it's not just a normal nozzle. It actually has little pills inside that need to be rinsed out, or they eventually block up with chemical. But the pills will decelerate water to the right speed, so we get a really nice consistent foam. The other thing is it draws air through here. That's actually what generates your foam with the pressure. I think we're using around the 40 bar, but we'll check the screen when we put it on. So, and then the fluid goes through there. So it's an all-in-one nozzle, just plugs in on the end of the hose. So we'll put it on now and test it to work. Okay, so here you'll see we're running at 70 bar. We're going to go to detergent. So what we're going to do now is run water through the chemical line where we just sprayed. We actually sprayed it with an acid detergent. So the idea of this is to keep the line clear, the check valve clean, and the nozzle at the end of the hose clean. Most cleaners don't rinse anything out, but I'm going to show you how it's supposed to be done. So we're going to move from the bucket of the water, we're going to turn the machine on, and then you'll see at the other end the nozzle rinse clear. And just a note there, I like to run hot water through because hot water cleans better than cold water. So now we know that that nozzle's nice and clean, the lines are clean, the check valve's clean, and everything will last 10 times longer. Okay, sweet. All right, so this is our main board. So on a weekly basis at minimum, we want to check the screen and our parameters. As we just demonstrated, different nozzles have different parameters, different environments have different KPA, depending if your factory is cold or hot, depending how hot or cold your water is. So you basically need to learn your machine, because then you want to see on a week-to-week basis that those parameters are in check, that they're not changing dramatically for any reason. So basically we'll go through the list. We want to check the hours. The hours tell you what the machine needs and when, how many hours you've done. Keep a track that the cleaner has done sort of consistent hours week by week. Our pump pressure, obviously the nozzle on the end of the hose will vary that. We can run, if that sensor failed, is not the end of the world. The oil pressure, very important. If the sensor is not working, this machine won't run unless the oil sensor is operating correctly. We use the 5.5 series, which is a motor range now. And basically you'll fail at 0 or you'll fail at 5.99. If you're reading 5.99, then the sensor is failed, and if you run out of oil, the sensor won't detect it. So oil pressure, our water temperature, obviously it's good to keep an eye on that, just to be in check that your plant water is doing the right thing. Not too cold, not too hot, nothing's changed. We're often on sites and I say, like, our machine just tells us what the plant gives us. So, but it's nice to know it's consistent and the same week by week. So that would be our minimum thing. The other thing, you also want to see that no water is leaking out from anywhere. Even the tiniest amount dribbling out, you want to know about it, because then we can investigate, okay, where's it coming from? A water leak's not going to stop you, but if you ignore it and no one ever checks it, it's going to turn into a big leak and then everything's going to get wet. Okay, so we're going to start at the back of the machine. That's our water in. That's our water out. Obviously that's a special high pressure quick connect fittings. While we're here, I just want to talk about, there's 3 O-rings in there. One's called top, there's 2 that are a bottom. And if they come out, just like any sort of quick release fitting, you're going to have a leak. So when you need it, you need it. We call that the O-ring. If the hose is connected in there, the O-ring shouldn't come out unless it's very old. But if cleaners run things without nozzles in them, there's a chance the O-ring can come out. So there are special O-rings for that. The next thing is the wire. So we've got a special fitting here that is made that you cannot pull this. It's a gland, obviously a Starner's gland. Your normal gland, cleaners will pull on it and then the wires come out. So this is a special gland that the wire will not come out. These are our pickup lines for the chemical. Blue matches foam, yellow matches the sanitizer. At the back here we've got the radiator grill, that is what cools the oil. So obviously if a forklift drives into it or anything like that, we want to notice any damage or any bends or anything. There is a nice space between the radiator and the grill, but the radiator is really critical for this machine to run. So that's that one. We're going to move around to this side. That's your HMI, which connects to the PLC. We'll talk about training on the electrical. Okay, so we're going to depower this machine now and then repower it, because I want to show you the 10-second warm-up for the flow sensor. I'm just going to turn that off. hone in on that flow sensor. Turn it back on. So you'll see here the light comes up. The flow sensor is warming up, goes for about 10 seconds. Okay, then we've got our reading, 0, 0, we have no flow. There's no light on, we have no flow. So I'm going to turn the water on now and then you'll see the flow. You see the orange light, and we've got about 15 litres a minute or so. So for this flow sensor to detect flow, you need about 4 to 5 litres a minute. The other thing, if you want to trick the PLC, you depower this machine. When you repower it, you press start immediately before that 3-second delay that we were talking about before. That means you'd actually trick the PLC if you need to do any testing. That's possible. So I'm now going to switch that back off. No flow, light goes out. Flow sensor is pretty straightforward. We use the SA4100. It either works or it doesn't work. It's that simple. If the probe gets damaged, it will stop it working. So yeah, it will no longer work. So when the cover is removed, which whether that's weekly or definitely not longer than monthly, first thing we want to know there's no visible leaks or weeps anywhere. And the other main thing is we want to check all our electrical connections. So basically these all have an M12 fitting. So just through normal sort of vibration, we want to know that nothing has gotten loose. Obviously if the lead is loose, then that no longer works. So according to where it's connected, you're going to have issues depending which electrical we're set up with, whether it's WEG or IFM. They'll be slightly different, but basically if the connection is loose, it won't work. So we have the connection at the flow sensor. We have the connection, this one is between the PLC and the HMI. We'll do further training videos on a separate time on the actual PLC and what's in this electrical box. So there's that one there. Then we've got the water pressure sensor, and then we have our oil sensor as well. So we want to make sure all of our electrical connections are intact, and this is dry. That sort of covers electrical. Obviously there's our oil level, which this is the breather. We also don't want the breather on really tight. So I'll take it off. I tell the boys that I should be able to undo it. It shouldn't be that I need vice grips or anything like that. So dipstick's pretty hard to see because it's plastic. But basically, if you look in the power end, there's a scallop there, and you should be able to see your oil just sort of shiny right near the scallop. So I'll touch on milky oil after we've covered the checks in a moment. Yeah, we want to know we've got oil. So that covers our electrical and oil. Now, oil leaks and weeps. That's the next thing, really critical. Really important because sometimes we get a message, oh, the machine's failed and it's got oil leaks, but it's not actually the pump. So under the head here, between the head and power end, are where our plungers go in and out. That is where your oil seals are. So if there's oil leaking there, obviously that is a seal. But sometimes it could be from overfilling or it leaking somewhere that it actually sort of cascades down, and it's a bit deceptive where it's from. So I usually run my finger on all these connections, especially here, which I'll get to the O-ring in a moment. So yeah, if there's anything weeping out from anywhere, you know, oil will leak out, but that will usually be an O-ring. So I just want to run through. Basically, this hose takes the oil out through the pump. This pumps it through. If we're going to have an issue, it's usually here or when it's touched. If you take your hose off and then try and reconnect it where the oil ring will fray. But this is the one where it usually has trouble, like it is running at pressure, sort of through here where the pump's pumping it out, then out and back through the radiator. The fan from the motor cools the oil, and then it's pumped back into the crank, and that's how we cool our oil. So I'm just going to grab a hose. So the O-ring's very small, and if it starts fraying, as soon as there's a fray, we're going to start weeping. It's just that simple. So you won't not run without it, but it's going to leak oil, you know, onto the platform. So basically there's the oil hose O-rings. You should have these on hand as a spare as well. So then with a pick you can just easily put a new one in and you're back to good again. So just put them back. The other thing to keep an eye on, because we had an issue with a machine that we lost oil pressure, like the machine will cut out at 30 kPa. So, and that's programmed that's still a generous amount of oil that you're not going to run out of oil. But we had an issue that this hose here collapsed. So just with hot running, it was running 80 degrees, you know, as a CIP system, that this hose degenerated and it collapsed. Therefore it restricted the oil passing through here. So the sensor is doing its job, but it's not enough kPa for the machine to run. So basically we sort of blame sensors and whatnot and going around in circles, but it was just simply this hose. So I would actually carry this hose as a spare, or even if you replace it every year, it's preventative maintenance. The way I tested it was, firstly I removed the sensor here to make sure we're actually pumping oil, because we wanted to see oil come out. Like this either works or doesn't work. It's an oil pump. So we did see the oil there, and like it wasn't a lot of oil, but it's not under pressure because the hole's like this big. So then we actually took this off here, connected a hose, and then we saw that the oil is pumping and draining, and that's what led me to this hose, which you wouldn't actually see as it's black and it's not obvious that it's collapsed, but it had collapsed. So we put that on, and then we're back to 200 kPa because we got down to like 10 or 15 kPa. So again, the sensor either works or it doesn't work. It'll read 0, it'll read the correct oil pressure, or it'll read 599. If it reads 599, you need to replace it straight away. I would keep that spare on hand. Okay, so next thing we want to check for leaks is unloader valve. These work pretty hard. They set our pressure. So if you turn the handle in clockwise, you're increasing pressure, and if you turn it anti-clockwise, you're decreasing pressure and allowing more water through the bypass hose. So there is O-rings in the unloader valve where you may not need the whole kit. If we do develop a small leak, they're a stem O-ring, and we can just replace a stem O-ring, but generally you just want to see there's no leaks. And again, it'll start as a tiny leak and then end up as a big leak. So the idea of this is you want to get it when it's a really tiny little weep and correct it, and then it doesn't turn into a major disaster. So on the inlet of the pump, we have our press fit pipework, which there's an O-ring for that. We generally don't have too many issues, but that is what we call the washer. So I would keep one of them on hand. Basically it's a union, so as it compresses and it wears, you know, eventually you could end up with a small leak. Just generally your hoses should be checked as well. You know, that degradation, that a small leak doesn't start. Over here we've got the fan, so you can hear it running. Obviously I can feel it running. So, you know, it's important that runs. It sort of cools the machine when the lid is on. We've got our glands here. That shouldn't be any problem there. They shouldn't really loosen over time. But again, just a quick visual inspection of everything is important. Now, at the back, we've got the radiator, as I said, that cools the oil. So, all right, so as you can see here, this is the PT5502. So it's the 55 series, the motor range. Takes a little bit more vibration. You'll see on the bottom here, it's actually got a snubber. So if there's a big hole in there, you haven't got a snubber, the snubber sort of takes your initial shock. So they'll last longer, they're much more reliable. So that's your 55 series. The other thing you want to check on a weekly basis, when you walk past this machine, it'll take you a couple of minutes to check those parameters and just a general check over, is your cleaner's hose, the cleaner's nozzles, and if you've got a hose reel in the equation, just to check that it's been treated correctly, there's nothing sort of starting to get loose, leaking, kinks in hoses, damage, things like that. Because if you see it before it breaks down, is obviously a whole lot better. So, okay, so as I said, the valves sit within there. So you've got your main components to this machine. You've got your water seals, your oil seals, and your valves. So Oil seals won't stop you running. Obviously, keep your oil topped up. Valves will stop you running. So there's two things to note. Firstly, if debris gets stuck in there, that it's in your water lines. If anything gets caught in there that this doesn't move up and down freely, the machine will shake. The other thing is just from general wear and tear, again, depending on what temperature you're running, the cages eventually wear down and they can crack. So once they break, if this breaks, you lose pressure and the machine's shaking. And if this happens, the best thing to do is just to turn it off, because you could cause further damage in there with this shaking around, you know, wearing through your brass head. So the valve seats on the O-ring. Now, if this O-ring gets hard and worn, it will change the tolerances. So then you'll get a slight shake in your hose. It's not shaking that it's unsafe to run the machine. And a very good cleaner will notice something like this. One that's not paying attention won't notice. But I usually say the easiest way to tell is that when the cleaner's working, their hose is on the floor, and wherever there's a pool of water, you'll see water flickering around. So if it's just flickering around a bit, you'll know the hose got a bit of a shake. It could also mean you don't have quite enough water if you're not getting in your 50 litres a minute, and you have that bit of shake as well. But it's just something to note. These should be replaced about every 1,000 hours. I have customers running for 2,000 hours that don't use high pressure. If they're just using the rinse nozzle and it's just idling, you'll get up to 2,000 hours out of it. And as I say, replace it when it's broken. Unless you're really worried about it, then you can just change it at the 1,000 hours, and that's by your hour meter on the HMI that I showed you. So that's your valves. Now, water seals. So we, in our machines, only use the saltwater rated seals. So you've got your duty ring. So you got your duty ring, and then you got your backup ring. So basically, if you got a dribble of water coming out from under your head when the machine is off, that means your duty ring's starting to wear. And then when you run and it takes up, we call it, so the leak disappears, your backup ring's doing the job and it's all good. But that is an indication that you want to change these. Quality of water definitely affects them. So you'll definitely want at least a Y strainer in the system. We've got places that we go down to 1 micron. So just depending on your water and how it's set up, the better your water, the longer these will last. It's that simple. So not sure of the material, but yeah, they're rated for the stainless head that runs in saltwater environments. So that's them. I've got a head here that I just want to show you. So the water seals are within here. And if you ever have one sitting around, do not leave them exposed to dust in the environment. So you'll see in there we've got the backup seal is closer to the back. Obviously that's a secondary one. And further in is your duty seal. So the brass rings around it. I didn't bring that up because basically you can clean your brass rings and reuse them. You don't have to replace them each time. So yeah, that's actually an assembled head. So in that port there, you'll see there's a valve and it looks good. I just usually look through my ports whenever I'm checking anything. If it's off, like if the unloader's off, for instance, because it can just show you, you know, the condition of it. The other thing, you can change these valves like without removing anything. You just remove these caps. It's a 32mm socket. We actually have a video on how to do that. I would change these on site in about 15 minutes myself, like pretty quickly. They're really straightforward. You seat your O-rings, seat your valves. There is a special tool that you can get from us that is easier than using like ball nose pliers. So yeah, that's your valves, and you don't have to replace anything else. If you have to fix it on the run, you know, you don't have to do everything all at once. So, but your valves is pretty critical.